Okay, this is the ITC 221 video for joins. So this is in the module joins and subqueries. I'm going to click on the chapter here. Again, this won't give you that, but if you go to external link, it will pop up the document. We're going to talk about joins, cross joins, inner joins. We're also going to do left, right, and full joins, natural self, and non-equi joins. Joins are basically combining tables. So I'm just going to look at this. Look at this table, which is the employee position, employee. So this is the employee position table. It's all numbers. It's mostly foreign keys, right? The only thing that's not a foreign key is the date. So when you want to understand the data, all right, so relational databases break things up and you end up with tables like this. When you want people to understand the data, you need to bring the tables back together and show like the employee name and the position name. All right, so I'm going to move this over here. And I'm going to go to PG admin and we're going to start a query tool. All right, and the first join we're going to talk about is a cross join. We're going to talk about it even though it is probably the least used or one of the least used joins. A cross join basically gives you every possible combination between two tables. So I am going to do select employee ID and position name. I need to look down here when we do position, job position, position name. And it's going to be from. We'll start with employee and we will do a cross join with job position. Now this one doesn't show any relationship. Normally when you do joins you have to show relationships, but this is literally just going to give you every possible combination. It's employee key. Alright, so there we go. So this is every single employee as president, right? Every single employee as grand manager. Every single employee as manager. It goes through and it does each of the positions and it shows you every possible combination. Okay, most of the time this isn't a particularly useful join. Where it could be useful, I suppose, is if you needed, they say, like if you needed all the same inventory in several different warehouses, you could populate them with a cross join. I want to show you, actually there's an alternate syntax for this, but I'm not going to show it right now. It's in the chapter if you want to look at it. But cross join is very rare, but it is something that is occasionally useful. What we're going to next is the inner join, which is always useful. It's the join you'll use the most. So let's look at this. Let's say we wanted to see the employee. We're going to just do a few things on the employee. Let's say we wanted to see the employee names. So if you look at employee over here in the columns, you see there's an employee key and a person key. So I'm going to do select let's do employee key first. Last name, person last name, person first name, and email. All right. So this will give us a list of all the employees, but it comes from two different tables. So we need to say from, and it doesn't really matter which table we do first, but I'm going to do person since that's where most of the things come from. And then I'm going to do inner join employee. Okay, and then we have to say how those two tables relate. On person dot person key equals employee dot person key. All right, so the person key in person is the primary key, and it's a foreign key in employee. So if I run this, it will show me the names and emails of every employee. Person email. Okay, so there we are. We have 7 rows, right? Because we have 7 employees. And then we have their employee ID, their last name, their first name, and their email. So that joins them together. I'm just this once going to show you an alternate syntax, and it's not one I'm going to use a lot because it doesn't work in every database management system. It doesn't work in SQL Server, for instance. So I'm going to do select, actually I just copy most of that. But instead of on, I am going to say using person key. And this will have exactly the same result. Okay, so that's an alternate syntax. Sometimes I use it because it's easier. But this, I think, gives you a better sense of how it's relating. All right, so let's keep working on the employee with the inner joins. I am going to do all of these. So let's just copy that. I'm going to copy from here. Actually, I'm going to just copy this whole thing. All right, but we're going to add a couple of fields here. A couple of other things about joins is you just put in the fields that you want to see. And you basically list, it doesn't matter what table they're from. Okay, so position name, and I think it's position start date. And again, we can look over here, employee position start date. All right, so the thing with this is we need to include a couple of more tables. I'm actually going to break that so it's all in window. We need to join again. So I'm going to inner join with employee position. And we're going to say on, how does that relate? It relates because employee dot employee key equals employee position. Spelling would be nice. Dot employee key. Okay, we're still not done because we also need to add the position, the job position. Inner join job position. And then that will be on job position dot position key equals employee position dot position key. Now, if I didn't spell anything wrong, that should give me every employee and their positions. Oh, I have a semicolon there from the past. Right. All right, and it does give me this error. And you may find this. The column reference employee key is ambiguous. And that's because employee key is both an employee and in job and an employee position. So we need to disambiguate it. I'm going to say employee dot employee key. It tells us what table we're taking the employee key from. And now when we run it, it will give us the names of the employees and what their position is and the date that they took that position. Notice Lynn has 3 positions. Several of them have more than one position. Okay. So that is inner joins. You can do inner joins as for if you have 20 tables to join, you can join them all with an inner join. All right. One last thing I will mention, the word inner is optional. You could just say join. Okay, so let's talk outer joins. These are a little bit different. Inner joins show related data. Anything that's not related will be left out. Outer joins can return unrelated data. All right, so we're going to do one with an outer join where just looking in the chapter here, I'm going to build this out. First we'll do select star from, let's not do select star. Let's select grant type. And I think grant type name, right? And we're also going to, we want to select something from grants, grant application. And let's just do grant application key. So we're going to say grant application dot grant type key. Okay, because we want it to come, we're doing 2 different tables, and the key is going to be in both, but the one we want to see is the one that's in grant application. And what we want to do is we're going to do this from grant type, and then we're going to do a join, but it's going to be a left outer join with grant application, and we need to again say how they relate on grant type dot grant type key equals grant application dot grant type key. And I'm going to add the word distinct here. just so we don't have to see so many of them. And let's run this. All right, so this shows the key, and it shows it in grant type right over here in the grants. Notice that funeral has a null and travel has a null. In normal inner joins, these two would never appear because they don't have a match. They're not matching fields. But in an outer join, it returns all of the fields on, in this case, left is the first table granted. If you did a right outer join, it would be the second one. But left is the top table, so it returns everything in grant type, whether it has a match in grant application or not. If it doesn't have a grant match, it returns it as a null. Right, so it lets you show the types of grants that nobody has ever applied for. I'm going to refine this a little bit more. I'm going to say where grant application dot grant type key is null. All right, so then we will only see the ones that have never been asked for. These are the types of grants that nobody has ever applied for. All right, and that's what outer joins are for, is to show you mismatched information. For instance, you could see something in an inventory that's never been sold. A type has never been sold. Or you could see a customer that's never in your customer list that's never actually done an order. You know, it's actually a really useful kind of join. So this is an outer join. The word outer is optional. You could just say left join. Okay, so I'm going to, you should read the chapter too, because I go into a lot more details. I'm going to do a little bit with inner joins and aggregates. This is a little bit out of order of how the chapter deals with it. So, a couple of things. Aggregates, as you remember, are things like sum, average, count, things that operate over multiple rows. So basically, I'm just going to, let's look at see how many grants. So I'm going to do select grant type name. Actually, so let's do this a little different. This is, I'm going to do select extract year from grant application date, and we'll make that year. And we're going to do sum grant application amount, and we'll call that requested. All right, and we're going to do sum grant status allocation. So this is how much was actually granted. So we'll call this as allocated. And then we're going to do a sum grant application amount. And we're going to subtract it. We're going to subtract the allocated amount to get the difference. And we'll call this difference. Okay. So we're going to get it from grant application, inner join, grant status, and we're going to do this as on grant application dot grant application key equals grant status dot grant application key. Okay, and then we have to group by. By the year. And we have to, I'm going to order it by the year. Okay, so we'll run that. Grant status. What is the actual? Let's look at grant status. Final allocation. And we need to do that here too. All right, it should work. Okay, so in 2020, the requested amount was 7,000, but only 5,900 and something was granted, and so there's a $1,582 difference. In 2021, there's a $3,400 difference. That's just to show you how you could do aggregates with joins. There is in the chapter, and you should read it. I'm not going to go over it right now. Some of the dangers with joins. Sometimes you get values that sneak in, and your sums are not quite correct. You should read that in the chapter. I'm not going to do it right now. Instead, what I'm going to do is go on to a couple of the other kinds of joins just real quickly. So let's do a natural join. Those are kind of nice. So I'm going to do, let's just do names and addresses. Select person first name, person last name, person email, and then we want employee key. I guess we're just going to do employees. And person address city. I think I want to do employee key first. And we'll get rid of it here. Okay, so, and this has to be city, not citery. All right. So I'm going to do from person. And I'm going to say natural join person address and natural join employee. And what it does when you do natural join is it just figures out the connections. This only works if you name your foreign keys exactly the same as your primary keys. So you can see that that's really easy as long as the keys are named right. It's a little bit, you're depending on it making the distinction. If by accident you have a second foreign key in there with the same name, it could get confused. Also, a lot of database management systems do not support the natural join, but as I said, they are kind of nice. There's also, we did with the outer join, there's another kind of join that does somewhat similar, which is called the full join. The full join, so let's just do this. So I'm going to just copy that. But instead of left outer join, I'm just going to do it as a full join. What full join does is it returns all of the records on both tables, whether they're matched or not. So because we said just where is null, it just returns exactly the same thing as the outer join. All right, is there any other kind of join here? There are self joins. I'm not going to go into that right now. I will do one non-equi join. Most joins have a equal in them. This is one where you have like a greater than. And it can be used for things where where things don't actually have a real relationship. I just copied it from the chapter. All right. So we're selecting the last name, first name, donation date, donation amount, and the grant application and the grant amount. There's no relationship between grant and donation. But we do get person, and we do a join. See, notice I left out the inner, but it is an inner join on person. Okay, and then we're joining grant application, but there is no foreign key there, so we're doing it on grant application date is between, so it's not equal to, but it's between donation date and donation date in an interval of 7 days. The idea is that the donation was in the same week as these grants. Again, it's a little bit weird, and it's something you'll never probably use much. But it does give us all of the donations that were within a week of their grant. And you could do it for just a particular person. Let's just do where last name equals Jameson. All right. This doesn't make sense anymore. So let's do that. So it shows the amounts 2020, 823. This is 25, 25, 26, 23. There were 4 donations of the same amount during the period. That's his donation amount. these are the amounts that were donated, actually given out. 220, 225, 200, and 200 for his one $3,000 donation. All right. I think that's it for joins. Read the chapter. All right. There's a lot more in the chapter than what we covered here. But we covered the basics. All right. So closing out the